The service we will be talking about will be EC2 or Elastic Compute Cloud. In short, EC2 simply means if you have to go and create a virtual machine or a VM inside AWS. Now, once we talk about VM or about the machines inside AWS, first thing to understand is what are the types of VM which are possible. Let's talk about that. By the way, if you want to know what a server is, a server hosts your backend, front end database. You have already seen a server actually when you were working on RDS and you talked about relational database services. There you went and created a database of MySQL. That database is actually known as a database server or a DB server. Similarly, when you went to document DB and you created a cluster, that was also a database server. So you have actually worked on a server day in and day out. The same thing, if you have to go and create inside AWS, that can be done. Let's get started with the types of the server. First thing, to understand the server types, we call this server as a instance inside EC2. Various clouds have their own ways of calling this. For instance, DigitalOcean will call it as a droplet, Azure will call it as a virtual machine, AWS will call it as an instance. Now, on what types can I differentiate my virtual machines or my instances? The answer is in front of you. CPUs, architecture, memory, storage type, network performance, and finally, based on the pricing. Let's get started with the architecture. First, any server that you create or any machine that you create has a processor. This processor has a specific architecture type. It can, nowadays, it can be either x86 or it can be ARM64. Example of x86 almost always is the processor which you are using inside your laptop or your desktop at the moment. That is your x86 processor. The Intel processors are the x86 processors. I'm pretty sure you are not working on a i386 processor. The reason is i386 processor has been discontinued already. Okay, so I'm almost certain that if you are not working on a very, very old machine, you won't be working on i386. Okay, so this was already discontinued, as you can see, on 2007. So any machine which you have bought after this won't ever be having a i386. Rather, it will be a x86 machine. Then what is this ARM processor? ARM processor or the ARM processors are the processors which are used inside your cell phones, inside your iPads, inside your watch. The small processors, which are not as complex as your x86, are known as the ARM processors. Now, first thing that comes to my mind is when I have my x86 processor, why do I need my ARM processor? Consider this x86 processor or the processor that you have inside your laptop at the moment, you just put your laptop working for one day and you understand how much heat it will generate. You have big adapters or chargers for that laptop. So first, it is pretty fast, yes, but second, it consumes a lot of battery power. You have the charger for your phone also, and you have the charger for your laptop also. The laptop chargers are way bigger. They consume more power. They also generate more heat. Now, if the same processor was used inside your cell phone, you would be needing that big charger and it would be generating that much heat. You might not even restart your cell phone for 7 days and it works perfectly fine. It is not heated up also. Okay, so your cell phones basically are working on the ARM processors and your laptops, generally speaking, are working on the x86 processor. However, that is not the case. Now there are new machines or new laptops which are no more working on x86 processors, rather they are working on the ARM processors. Example of this is MacBook M1. So MacBook M1 chip which has been released is all working on the ARM processors itself, this one. Okay, so M1 first of all works on ARM processors. That is why for that reason it is pretty fast also. For that reason it has better battery life also. Okay, so these laptops are working. So for that reason, if you go for any of these MacBooks, actually, you will get two options. Either you want to go for the ARM processors or you want to go for the x86 or the Intel processors. Okay, so if you go over here, no, you have the M1 chip with this one. So you have the option to go for either ARM or you could have gone for your Intel processors. Okay, this one is x86 processor, which is at this much. This one is Apple M1 chip, which is ARM processor, which is at this much. Looking at this itself, you can understand which is the cheaper option. Okay, so ARM processors. Okay, by the way, it was said earlier that that x86 processors are faster than ARM, and indeed that was the case. But the new chips which are coming up nowadays, the ARM processors are actually faster than your x86 processors. Also, they consume less power. Also, they generate less heat. So it's better to work on your ARM processors. Okay, so the servers that are actually created will have option for either going for the x86 processors or the ARM processors. Okay, so ARM is something which starts with A. So first thing to understand is that if I have to differentiate the things based on the processors, it will be the based on the architecture, and it will either be a ARM processor or it will be a x86 64 processor. Almost everything that you see will always be a x86 only. ARM is a very new thing, means as in it came back 2 years back itself inside AWS. So it's a very new thing, and you will find very less server types for it also. So that's one, based on the architecture. Second thing is based on the memory, how much RAM your server is having. It can have 512 MB, it can have 1 GB, 2 GB, 4 GB, 8 GB, 16 GB, and 32 GB. And it can actually increase a lot also. So it can be based on that also: 4 GB, 8 GB, 16, 32, 64, 96, 128, 192, and so on. So it can be based on your memory also. Then comes the storage. Now, once we talk about the storage, there are two types of storage which are actually used inside your AWS instances. Let's talk about that right now. So first, if at all we have to talk about the storage part over here, storage is the hard disk which is being used inside your laptops at the moment. Okay, you would call it as a hard disk or you would call it as a SSD or a storage device. Okay, in short, your laptop saves some data for future use, so that even if your machine shuts down, still the data is actually saved somewhere. This somewhere is actually known as your storage. AWS has its own storage, which is known as EBS or Elastic Block Store. Inside this, you can go and create something known as a volume, and this volume can later be attached to your server. Example of this, you have a pen drive that is actually a volume. You plug it inside your laptop, you are actually attaching it to your laptop. You remove it from the laptop, you are detaching it from the laptop. So that pen drive is a volume. You plug in an external hard disk, that is a volume. You plug in another pen drive, that is a volume, and so on. Similarly, if you have to go and create a volume inside AWS, you can, for that, you can go to your Elastic Block Store, click on volumes over here, and select what is the size of the volume that you need. It can be 1 GB, 2 GB, 3 GB, 4 GB, 5 GB, 100 GB, 1000 GB, 10,000 GB. Basically, whatever size you want, you can go and create that volume of that much size. But there's one catch over here. It cannot be 1.2. It cannot be 1.3. Even if you try typing the dot symbol over here, it won't work. Volume will be of 1 GB block itself, either 1 GB or 2 GB or 3 GB or 4 GB or 100 GB. You want 1.5 GB, that is not possible. You can either have 1 GB or you can have 2 GB. So that's also a big difference between your S3 and your EBS. S3 was your object store. Object can be of 1.5 GB, which means AWS will charge you for 1.5 GB. EBS or Elastic Block Store will be of 1 GB always. So in case you need blocks of 1 GB or 2 GB or 3 GB, you can go and do that. So that is what is meant by your EBS or your volumes over here. Now, over here we see multiple options: GP2, GP3, IO1, IO2, SE1, ST1, and standard. Let's talk about that. Whenever we talk about volumes, we have actually seen this earlier. Let me take you back to your RDS, where we had gone and created a MySQL database. Inside this, when you were going and creating a database and you were saving the data inside some volume, you were actually putting the data inside some storage place. What was that place? It was actually telling you, let's go and say it once. So I decide to go and create a database of, let's say, MySQL, and here storage type. You see, it is giving me two options. I can either have a IO1, or I can have a GP2, or I can have a magnetic. Remember, provisioned, general, magnetic. Going back, provisioned, general, and magnetic. So what is this? Let's talk about this now. So let's say you don't have any specific performance in your mind. You just want a general purpose hard disk to be attached to your device. In that case, you can go for a GP2. GP2 you have already seen, by the way, inside your RDS. You have certain IOPS in your mind, which simply means input output per second. Example of this is, let's say 200 people or 200 transactions are happening in 1 second. That IOPS is actually 200 or 2000. 5,000 people are trying to log. At a very layman term, 5,000 people are trying to log into my server, and assuming only one transaction is happening, it is actually IOPS of 5,000. So the more IOPS you need, and if you have some specific IOPS in your mind, you can go for either IO1 or IO2. Now, IO1 and IO2 is good because the ratio is 1 to 50. What does it mean? If I want 10 GB, I can have 500 IOPS, okay, over here, because the ratio is 1 to 50. So if I have 10 GB of storage, I can have 500 IOPS. If I need 501, that is not possible. If I need 400, that is possible, because minimum ratio is 1 to 50. So what does IO2 do? IO2 is exactly better version of it. So let's say if you have 10 GB, the ratio is 1 to, okay, let's go back to IO1 and see once. 10 GB, I could have gone for 500 only, okay, not 501, only 500. Ratio 1 to 50. IO2, on the other hand, has ratio of 1 to 500. I can even make it 5,000. 1 to 500, but I can't make it 5,001 again. Okay, so in special scenarios where you need specific IOPS, you can go for either IO1 or IO2. Fine. This is about the provision. Then comes my cold HDD and my throughput optimized HDD. HDD is required when you are not worried about your IOPS, rather you are worried about the throughput. Throughput simply means I am copying the data from my hard disk to my pen drive at maybe 10 Mbps, at maybe 100 Mbps. I need that sort of bandwidth with myself. In that case, I can go for a cold HDD in which the ratio is 12 Mbps per terabyte, which means if I go for 1024 GB, it will be 12. If I go for double of it, or 2 GB basically, or 2 terabytes rather, it will become double of it, 24. That is your cold HDD. On the other hand, a throughput optimized HDD ratio is bigger. Earlier it was 12 Mbps for each terabyte. Here it becomes 40. So if I go for 1024, it will actually become 40. In this one, it was actually only 12. Okay, so in cases where you need specific bandwidth, in that case, you can go for either a cold HDD or a throughput optimized HDD. In this case, your bandwidth is maintained. Better performance, go for throughput. Lower performance, go for cold HDD. And finally comes in magnetic. Now, there is no case in which you would want to work with a magnetic disk. The reason is it neither has your IOPS nor your throughput. So just in case you want, you can go for magnetic, but again saying there is no use case where you might want to go and work with a magnetic disk or a magnetic storage. So we understand what IO1, IO2 is, SC1, ST1 is, magnetic, GP2 and GP3. GP3, by the way, is the newest volume type of AWS. It was introduced in December last year, actually. Okay, so it's pretty new, hardly been 8 months since it was actually launched. The advantage of this is, if you remember, GP2 only had IOPS. IO1 only had IOPS and no throughput. IO2 also IOPS and no throughput. SC1, ST1 only had throughput and no IOPS. GP3, on the other hand, will have both IOPS and throughput. So basically, if you want your volume to have both IOPS as well as size, or let's say the throughput, in that case, you can go for your general purpose version 3 or GP3. GP is not available as of now because it's pretty old. So you have GP2, you have GP3, IO1, IO2, SC1, ST1, and the magnetic disk. Now, let's say that you decide to create a volume. So let's say I am going for GP3 and I'm going for 8 GB of volume. I can choose the availability zone where I want my volume to be kept. It can be 1A or 1B or 1C. Remember, if you have created inside any of the availability zone, there is no way by which you can change it from 1A to 1B or 1A to 1C and so on. If it is inside 1A, it will always be inside 1A only. Keep that in mind. Also, because you already understand the service of KMS or key management services, wherein we had gone for the key option, wherein we had talked about the symmetric and the asymmetric key. In that case, if you want your data inside your volume to be encrypted, that can be done via the master key over here. Okay, so you are encrypting the volume with whatever thing you have. So I am choosing this key. And if in case you want to go and give it a name, I am putting it as V1 over here, and I click on create volume, and my volume is created inside 1A. This is my EBSO, Elastic Block Store Volume. Now, let's say I want to take a backup of this volume. So assuming that I have some real data inside my volume, I can do that by simply clicking on actions and clicking on create snapshot. So let me call this as this is the backup, and let's go and name it as S1 or snapshot 1. If I click on create snapshot, my backup of my volume V1 has been created. Where is it available? Inside my snapshots over here. So you see this S1 over here, which was created on October 7, some time back. So let me go and delete this first. Okay, fine. Just give me a minute. Okay, so I have my snapshot, which has been created. Please note that a snapshot doesn't have any availability zone. Snapshot works at the region level. Volume works at the availability zone level. Okay, so if in case you have to change this to 1B, you can very well do that by clicking on actions, clicking on create volume, and you can choose the new availability zone where you want your volume to be created. That is a possibility. So this is how you can take the backups of your volume, and this thing is known as a snapshot. Now, this backup, if you want, you can send it to a different region. Also, for that, click on actions, click on copy, and you can select the new region. So let's say if I select Stockholm, my backup or my snapshot from Mumbai or AP South 1 will be migrated to Stockholm region. Okay, whatever region you have selected over here. So this is how you can do the migration of the data from one region to the next region. By the way, you could have also gone and copied this to a different account also. For that, you can click on the permission and you can click on edit and you can add it. The reason why this is not being allowed as of now is because you are having a key which is used to encrypt. Let's say I want to go and create one more. So let's go and do that. Let's say GP3 and of 8 GB. And let me just name it as, let's say, I can be copied. Volume is created. And from this volume, I will go and create a new snapshot. So let's say here, actions, create snapshot, and I will add a name over here and I will say this. Now this snapshot I can be copied is available over here. If I want, I can click here, I can click here, I can click on modify permission, and I can give it on a different account number also, which means that my snapshot can also be copied from one account to the next account. Now, the reason why previously it didn't happen was because I was encrypting my volume and that person does not have access to my keys, because that's the whole point of having KMS or keys, that you cannot share the keys. So even if you share the volume, no one understands that, or it cannot be decrypted basically. So for that reason, that volume couldn't be copied or transferred to the next person. So this is your snapshots. We have seen both the ways of creating the snapshots. Now there is one more way by which you can go and schedule the backups. So let's say I want a backup to be created every day at 6 a.m. and 6 p.m. and 6 a.m. and 6 p.m. Basically, I want my backup or my snapshots to be created at interval of 6 hours. And I want the backups to be deleted automatically after 30 days. Now, if you remember, you have already seen it earlier inside something known as AWS backup, where I could have gone and created my backups automatically. So that is one way of doing it. Yes. Alternatively, you can go and work on it using the lifecycle manager. For that, click on create lifecycle policy over here. Give it a name. So let's say I am saying this for this is the automated backup here, and this will be applied to anyone whose name is V1. So basically, any volume whose tag name matches V1, this backup will be applied. And what will happen? I have to create backup every 6 hours, right? So I will select this and I will call it as backup every 6 hours. And this will happen at 18:30 hours. Remember, the time is in UTC. So if in case you want it to be done at 12 a.m. in the night, you will have to convert it to UTC time. So because my region is Mumbai, so I am selecting 18:30. Also, I said I want to retain the backup of last 1 month. So for that, I will make it age. I will call it 1 and I will say 1 month. So what will happen? A backup of my volume, which volume? Whichever volume matches V1 will be created every 6 hours starting at 12 in the night, and it will be retained for 1 month. Now, you can also say that I want to copy this same backup to a different region also. In that case, you can select here and you can select, let's say, I want to send this to Stockholm. And this should also be retained for duration of 30 days. Done. Now, let's say you have to send it to some different account altogether. You can do that by clicking here and giving the account number of the next person. That is a possibility. Next, let's say I want to create a daily backup also. So one backup I want to create every 6 hours. One backup I want to create every day. For that, I can click on add additional schedule and let me call it as daily backup. And I'm saying create it daily over here every 24 hours, starting at 18:30 hours. And this backup, keep it for 1 year. So I will have 12 daily backups, as in I will have 365 backups at the end of the day. Now the same old story, if you want, you can go and put it inside a different region. You can share it also. Now let's say this was, you have taken backups every 6 hours. You have taken a backup every 24 hours or 1 day. Let's say you want to take a monthly backup also. In that case, add additional schedule, go and do that. Let's say monthly backup. And this backup should be done every month on the first day at 1830 hours. And this backup, I want to keep it for 7 years. That can be done. Something like this you have already seen inside your S3 lifecycle manager, wherein you could have gone and created your policies. So if you go and do that, again, the same old story, you can go and copy it to a different region. You can share it with different person also. And if you go and create this policy, a policy is created inside AWS, which will create a backup every 6 hours, keep it for 1 month, create a backup for every 1 month, keep it for 1 year, and create a backup every 1 month and something, keep it for 7 years, or whatever policy you have created. So if everything is good, this backup should be created. And if you want to see how it will work, you can click on schedule and you can see this backup will happen every 6 hours. You keep it for 1 month. It will happen every 24 hours. It will be kept for 1 year. It will happen every month, and it will be retained for 7 years. So basically, if you want, you can also share it with someone. If you have enabled it over here, can be shared. If you want to add any tags, you can do that. If you want to go and change it, you can click on modify policy and you can change the lifecycle policy again. Though a preferred way of thinking about it is you can go and straight away create a new policy. That is actually easier as compared to going and editing your policy. As you can see, it takes some time. So the error that I see people doing it, you start to panic basically, that is it actually working also or not. So though you can do that, but my advice will be go and delete the policy and create a new policy. So that is about your Elastic Block Store or your Lifecycle Manager, volumes and snapshot. So if in case you have to go and delete the policy, pretty straightforward. Just select the policy, click on delete policy. And if you delete it, basically the policy is deleted. The backups, whatever are there, will continue to be. Only the thing is new backups won't be created. Now comes the next part. Let's go back to our instances. And inside this only, we'll be talking about multiple instance types. First thing first, I click on launch instance, or I go and work on a virtual machine. In this case, AWS is giving me multiple options or multiple operating systems, whichever I want to go and buy. So I can have like, let's say you go to a shop and you say that I need a Windows laptop or I need a Mac laptop and so on. Okay, so Windows, maybe you go for Ubuntu. So this is exactly what AWS is saying, that whatever operating system you need, you can have it, either Amazon Linux 2, RHEL, SUSE, Ubuntu, Microsoft. Now, in case you say that where is MacBook are also present now, but the only thing is it is not present in all the regions. It is present here, it is present in Singapore and some specific regions. Let me show you that and then we'll come back. Okay, so in this case, if I go to North Virginia region over here and I go to my instances, and assuming I want to go and create a instance of, let's say, Mac, I have that option. I have option of Mac OS Big Sur 11.6, 10.15 and 10.14. So in this case, you can go and select that also. In this case, the only thing is you won't be having x86 or ARM, because Mac machines are single machines itself. So you can go and select that, and then the next page you can select the type over here. Now MacBooks don't have any other option except one, because you are given a single machine itself. Okay, so you don't have any other option over here. Fine, let's go back to our classic machines. In most of the cases, you actually use either a RHEL or a Ubuntu machine. So assuming I am taking a Ubuntu machine, I have two options. I can either go for the x86 or I can go for the ARM machines. Now, majority of the servers that you see in the world are working on x86. So I'll be choosing a x86 machine. I'll be clicking on select over here. And now let's talk about the various instance types that I see. First, you already know based on the architecture that you have already decided previously that you were going for x86 machine or you were going for the ARM machine. Assuming I am going for the x86 machine, I see something as family over here. I have a T family, T3A, T4, C4, C5, C6, G4, M4, M5, M6, R4, R5, R6, and so on. So first of all, let's understand what it means. So whenever you see A in the end, it simply means it's a AMD processor. There are two types of processor which are available actually primarily which are used, Intel and AMD. So you might want to go and have a look at this one. So Intel processor is also present, and you have your AMD processors which are also present. Both the companies are there. So you have your AMD also and you have your Intel also. Whenever you see A in the end, it simply means it's a AMD processor. This server is working on AMD processor. You have T3A to T3A2X large. Similarly, you have C5A. Similarly, you have R5A and so on. Okay, so AMD processors. Next part. Whenever you don't see A in the end, it means it's a Intel processor. Keep this in mind. Next, whenever you see this T is the family. So like you have T2, after some time when new things happened, you went into T3, new thing happened, you went into T4. So T2 is the oldest version, followed by T3, then followed by T4, and the latest one is your T4. Now, what is G over here? G is the Graviton processor. Graviton processor, like Apple has their M1 chips, Apple has their M1 chips rather, AWS has Graviton chips. They call it with the word G. So whenever you see G over here, it simply means it's a ARM machine. You see T4G, go down, C6G, Graviton, go down, RM6G, Graviton processor, go down, R6G, Graviton processor. Now the reason why this is disabled is Graviton processors are the ARM processors. And in the previous step, you had already said that I want the x86 machine. So if you are going for x86, the Graviton processors won't work. Okay, so going back, I have T2, I have T3, the next generation normal Intel processors, T3A, next generation with AMD processors, and then comes T4G, which is the Graviton processors or the ARM processors. Next part, what is this T, what is this C, what is this M, what is R, and so on. Let's talk about this. There are certain softwares which will require very high compute power. The processors should be better. Example, blockchain. Example, Cassandra. Example, IoT. So whenever you need more compute power, you go for the C types of the instances, stands for compute. You can go for C4, which is old, C5, which is new, C5A, new with AMD processors, or you can go with C6 and the Graviton processor. So whenever you need more compute power, you go for the C types of instances. Whenever you need more RAM, more memory, you go for the R type of instances. For example, you see R4, R5, R5A, and R6. R machines are the machines which have more memory or RAM. The softwares which will work on more memory are any of the databases. So that's the reason why when you had gone for any of the databases, let me take one example of DocumentDB, the only database type or the machine type that you were seeing over here was a R type of an instance. Let's go back and see. I click on create over here and you only see R instances over here, right? The reason for that is This is the instance that requires more RAM. Database will always require more RAM or more memory. For that reason, I have the R instances here. Okay, so C for more compute, R for more RAM. Then there are the general purpose instances. I just need it for general work. I have to launch a website. I have to launch something in backend. How will that work? That works on the M type of instances. M type of instances are the general purpose instances. So you have your M4, then you have your M5, M4 Intel, M5 Intel, M5A with AMD, M5A is with AMD, and then you have your M6, which is your Graviton processors. Now, if you have gone for any of these instances, let's say you have gone for 2 CPU, 8 GB RAM, AWS will only give you 2 CPU and 8 GB RAM and nothing more and nothing less. 2 CPU, 8 GB RAM, that's it. Whether you use it or you don't use it, you have to pay for whatever resources you have used. Okay, so there is a possibility where I say that I need more resources. See, I don't know. I think I will need 2 CPU, 8 GB RAM, but maybe for a short burst or for, let's say, 10 seconds or maybe 1 minute, this can increase. There is an instance type that can help you for that also. That is known as your T instances. T is the burstable instance. You are going for any of the T instances, then it means that if in case you need more resources for a small burst or for some small time, you can do that. T instances are known as the burstable instances. Now, let's complete it by talking about few other things. So first of all, D over here. There are certain instances which have the disk attached to their servers itself. This is known as the D type of an instance. The storage that is attached is something known as an instance storage. Now, the advantage of instance storage is that this disk is attached at the hardware level. It is actually next to your processor itself, next to your server itself. For that reason, this instance store is very fast. But it will only happen in the instances which have D attached to them, disk. Okay, C5D, go down, you see M5D, all are attached. M5AD, all the instances, AMD processor with the disk attached. Similarly, C6 or any of the C instances will also have the disk attached. That is known as the D instance, which have their volume attached with the instance itself. Now, last thing is known as the N instance. N stands for network. You need more bandwidth. So take an example of this. My C5N over here supports 25 gigabit of store transfer. C5 large is 2 CPU 5GB. It supports up to 25. Go up and look for C5 large over here. It only supports up to 10 gigabit. So whenever you need more bandwidth, your instance has to work more at the network level. In that case, you need a N instance actually. Okay, so this is the instance types that you will actually need. Now, going to the actual production environment, what type of instances will you actually work on? The answer is, if it's a database, it's a R instance by default. Okay, it will always be a R instance, which you have also seen. R instances. If in case you are working on blockchain or maybe IoT or maybe some things which will require more compute power, like Apache Cassandra database in short, in that case, you will go for the C type of instances, which are the compute instance.
You have to work on any general purpose thing. Let's say a web server, a simple backend, a simple front end, maybe a simple database. In that case, you can go for the M type of the instance. And finally, a burstable instance will come in case when you need sudden burst. Let's say right now I need 2 CPU and 4 GB RAM. After half an hour, maybe for 1 minute, I will need more CPU and more RAM. In that case, you can go for the burstable instance or the T type of instance. So this is how you will go and work at the instances or work with the instances. Now, in the previous step, I had already selected Ubuntu Server 20. Over here, I will go and select, let's say, T3A uh, small, which has 2 CPU and 2 GB of RAM. It will support only EBS. It has IPv6 support also, and it will have up to 5 Gbps. Next comes the instance details. First, how many instances do you actually need? 1, 2, 3, 4, whatever. If you need more instances, you can go for that also. Let's say if I need 10 instances, I can put 10, which basically means it will automatically go and create 10 instances for me. You can go and work with the spot instances also, which we will see very shortly. Network and the subnet you automatically know that we have done inside our VPC itself. So let's say it has to go inside my VPC and it has to go inside any of my subnet. I choose 1A. It means my instance will be launched inside 1A availability zone itself. Also, I want my instance to have a public IP. In that case, I can either choose enable or I can choose disable. If I enable it, it will have a public IP. If I don't enable it, it will not have a public IP. Directory services you have already seen. If you go and create a directory using Azure Active Directory, it can go and join to that. But in that case, you will need to have a Windows server. Obviously, IAM role you already know anyhow, right? Because if you go and you want your instance to go and work on certain specific things or certain specific services of AWS, you can go and select that IAM role which you have created. Next, once your instance stops, what do you want the instance to do? Do you want it to stop or do you want it to terminate? I want it to stop. So I'm selecting that. If you want, you can also support hibernation. In this case, the instance will hibernate. Then if you go and check this option, it means that your instance cannot be terminated even by mistake. Though for this, you might want to go and create a special policy so that no one can go and ever terminate your instance. So attach it to the user or attach it to the groups and they cannot go and terminate any of the instance. You want the monitoring. Now, AWS will obviously give you the monitoring upfront, but you want some detailed monitoring. I want it at the second level. In that case, you can go for detailed monitoring. Obviously, it will go and have additional charges for that. Tenancy, you can run it on a shared hardware or a dedicated host or dedicated. Now, in short, it simply means that let's say AWS has a big server of 10 CPU and 10 GB RAM. Out of that, 1 CPU and 1 GB RAM has to be used by you. So that is something known as a shared hardware. So 1 CPU, 1 GB RAM by you, 1 CPU, 1 GB RAM by someone else, 2 CPU, 2 GB RAM by someone else, and so on. Dedicated instance means that this instance will be created exclusively for you, and dedicated host actually means that this particular server complete of 10 CPU and 10 GB RAM will be used by you only. We are going to talk about this very shortly. Okay. In my case, I am going for a shared hardware instance. In the next step, you can go and select the storage, what type of storage you need. Now, if you remember, we had already seen GP2, GP3, IO1, IO2, and magnetic. You can select any one of them. The throughput optimized HDDs are not available in this case. So I'm going for a GP3 volume. And if you want, you can also go and enable encryption. This is encryption at rest, which means that whatever data is inside your volume at this moment will all be encrypted. Next, if you want, you can go and name it. So I'm going and calling it as I1. Next, security group. This you have already done inside your VPC, but still, let's say that I have to go and work on it as a web server. In that case, because it's a web server, I will go and also enable the HTTP traffic over here and anywhere. So let me call this as, let's say, web-server-EC2. And description I can give SG for web server in EC2. Okay, now if I go and launch it, I can go and launch my server or my virtual machine with a key that you have. Now, if you want, you can go and create a new key and you can download it. Because I already have a key, I will choose an existing key pair and I will go and launch the instance. Now, if the instance is actually launched, you can go and make a connection with that. It's pretty straightforward. How? Let's go and talk about it. For that, you just have to select the instance, click on the connect button, and you can either use a SSH client, or you can do a session manager, or you can do instance connect. Instance connect basically will open the connection inside the browser itself. So if you see, my browser itself can be used to connect with my instance. Have a look at the private IP. It is 172.31.47.0, which is the same private IP over here. So let's work on the instance now. More about it, the commands that we do, you will learn inside the DevOps class. But for now, what I will do is I will just go and create a web server inside it. I will basically go and install Apache inside my web server. So for that, sudo apt-get update over here. And once that is done, I will go and install Apache 2 inside this. So let's do that. Sudo apt-get install Apache 2. And if everything is done, my instance should be connected with the web server, and it should have something as a web server coming up actually. To confirm that indeed it is working, let me take the public IP of the instance here. So this one, and if I go and put it inside a new tab, okay, I didn't copy it properly, I believe. Yes, here, if I go and do this, I should see something coming up like this, Apache 2 Ubuntu default page. Now, because I want to actually see if indeed it is working or not, let's go and make a change. So let's make a connection here, and I click on connect. It says that if in case you have to go and change it, you can go and change this file. So what I'll do is I'll just go and change the content of the file, reload the page, and see if it works. So for that, here, and the title, you see over here, the title is Apache 2 Ubuntu default page. I will just go and change it to, let's say, Saurabh right now. And if everything is done, if I just go and replace or refresh it, you see Saurabh coming up over here, right? Which means that indeed I have been successful in going and creating an instance, and it works, or it installs a web server inside it. So this is how you can go and create a web server. Let me also go and name it as Saurabh itself over here. So I have this one server over here. Now, let's say people are trying to hit my web server. There is a possibility that my web server actually goes down, or this instance is out of capacity. It doesn't have any more bandwidth. It cannot support any new instance now. So in that case, I will need one more instance to work in parallel. So basically what I need is I need two instances to do the same job for me. If you remember, you have already seen this at multiple places. Let me show two examples of it. So let's say I go for RDS and I go for my classic document DB. One SQL, one NoSQL. So if I go inside my document DB and I create my cluster, this cluster can have multiple machines at the same time. So it will ask me that how many machines do you actually need inside the cluster? So it says how many instances do you need? I could have chosen one and I could have chosen three. Now, if one goes down, my entire cluster goes down. So what I do is I actually create 3 machines. Same thing inside my RDS. If I had gone and created my database over here, and if I had gone and selected over here, no, so how do you want a multi-AZ deployment? So basically what happens is that if one instance goes down, the next one is still up and running. So going back to my document DB, I can have multiple instances which are working in parallel, so that if one instance goes down, the next one is still up and running. This concept is known as a load balancer. In short, a load balancer will do the distribution of the work amongst multiple servers. So consider it like this. Ashfaq, Saurabh, Masood are all via the internet. They are hitting the load balancer, and the load balancer is sending you either to machine 1 or to machine 2 or to machine 3 or to machine 4. So load balancer is sending you to 1, 2, 3, or 4, any one of them. Now, if machine 1 is down, no worries, 2, 3, 4 are still up and running. After some time, 1 will come back again and it will be added to the load balancer. And the data will start to flow into 1, 2, 3, and 4, all 4 of them. If 2 machines are down, no worries, my 1 and 2 are still up and running. If 2, 3, 4 are down, no worries, my 1 is still up and running. After some time, I can go and add machine 2, 3, and 4. Or the moment they are rebooted, they will automatically be added to the load balancer. So that's the story of your load balancer, basically. You can go and balance the load or route the load to multiple machines in real time. So how to work on a load balancer? Let's get started with that. Before that, just understand few things. Load balancer has to know if all the machines are actively working in real time or not. For that, a load balancer sends a message to any of the machine, and the machine has to reply back. So generally what happens is a load balancer sends a message to the machine asking, I1, are you up and running? I1 has to reply back within 5 seconds. If it replies back, good. If it doesn't reply back, no worries. The load balancer will again ping the machine after 30 seconds and say, I1, are you up and running? If I1 replies back, good. If not, load balancer will remove this machine from that particular load balancer. But still, after 30 seconds, it will again ping that machine. Are you up? If it says yes, it won't add. It will wait for 10 successive times when it reply back saying that, yes, I am all good. And then the load balancer will add this machine to itself. But this is all stories. Let's actually go and work on a real-time load balancer to see it live in action. For that, I had already created a machine known as Saurabh. Let me go and create another machine as Ashfaq. So for that, I click on Instance. I select Ubuntu 20 and T3, a small instance. Here, I am selecting it inside, let's say this time inside 1B. Storage, I am going for a GP3. Tags, let me name this machine as Ashfaq itself. Security group I had already created, if you remember, which was something as EC2. Web server EC2. It is enabled, no good. Launch, and I acknowledge and I launch the instance. Now the same old story, I will go and install the web server inside the machine known as Ashfaq. So let's just refresh it once. And if everything is good, let's connect with the machine. This, connect. Okay, sometimes it might not work. The reason is we have tried to connect it straight away. Okay, that doesn't work. So just wait for some time. In the meantime, it's good time to actually go and have a look at something known as status check. 2 out of 2 checks. Now, many companies actually do ask about status check. So there are two types of status check. One is an instance status check, and the second is the system status check. Instance status, okay, first system status check. System, maybe this is a problem with the AWS itself, that your server is not responding or working. That is known as system status check. Maybe there is some problem with your server, your configuration, your operating system. That is known as instance status check. So whenever you say no, that instance is not responding or it's not working, it's not reachable, there can be any of the two errors. Maybe AWS itself is having the problem. That is system status check. Maybe there is a configuration problem at your level. You have messed up your machine. You have deleted some important files. That is your instance status check. Okay, so for a machine to be working properly, both the status check should actually be working. So for that reason, if you see this machine over here, no, this is still initializing because it is still passing the status check as we speak. So for now, let's make a connection with this one, the machine Ashfaq, and click on connect. Now it should connect actually. So for that, let's go into the same old story. We'll install Apache Web Server over here actually. And then and why. Now, if you remember last time, if everything is good, if I open my public IP, I should actually see something coming up, the web server actually, right? And I do see my web server coming up. But then again, what's the proof that this is a Ashfaq machine? So for that, what I'll do is I'll just go and change the name again over here, sudo nano this, and inside the title, I'll just go and write Ashfaq here. Okay, and let's go and refresh it. And I see Ashfaq coming up on the top over here. Okay, now if both the machines are working and my story of load balancer is all true, let's go create load balancers and see for ourselves. For that, I click on load balancing and I click on load balancer. Now, very important, this is always asked in the interviews, what are the types of the load balancer? The answer is there are 4 types actually: classic, application, network, and gateway. A classic is the old one, not used anymore. Application load balancer is used when you have to work more on the web servers. Network is used when you have to work more at the network layer, when you have to talk about millions of transactions. Gateway load balancer is pretty new. It is used for third-party appliance actually. So you won't be seeing gateway load balancer actually more. You will be seeing either a NLB or a network load balancer or a ALB, which is your application load balancer. You'll be seeing more of them. So though anyhow, right now we are going to work on all of them. So let's get started with the first one, something known as my classic load balancer. For that, click on classic. Also remember, AWS is retiring it in next 8 months. Okay, so 8 months, sorry, 10 months as of now. So this won't be available anymore, but still let's go and see what it was. So for that, let me go and name it as CLB, or a classic load balancer, which is working on port number 80. Next, I can use any of the security groups. I am using this security group because I think it allows port number 80. Now, if you want to create it on your own, you can do that. It will go and enable port number 80 over here. Okay, so port number 80 from anywhere is allowed. Next, I will go and say that, if you remember, I told that I will be pinging my load balancer instance, which has to respond back in 5 seconds. It will ping you again after 30 seconds. If you don't respond back 2 times, you are gone. If you respond back 10 times, you are added. Though actually, if you want, you can reduce it also. So if you just respond back 2 times, you are actually added to the load balancer. Then next step, I will add my EC2 instances, actually both of them. Tags, if I want, I can name it. So let me call it as a CLB hyphen load balancer. And if I go and create it now, my load balancer has actually been created, and this load balancer will eventually point to either Ashfaq instance or to Saurabh instance. To test it out, go here, hit this, and in ideal scenarios, it should give you a response. As of now, it is not giving you a response. And the reason for that is that this load balancer, if you remember, I told you that load balancer will be pinging the instance. It needs a response back. Until it responds back 2 times, which is decided by my health check, I won't be adding it. So right now, actually, the registration is still in progress. So in some time, we will see that these instances are added to the load balancer, and eventually this will become in service, and this will start responding to me. Okay. While the instance basic health checks are being done, let's go and create the next load balancer. Next one is something known as a ALB, or a application load balancer. So for that, I click on create load balancer, application load balance. There's a bug, I believe. Just hold on. Okay, anyhow, going back to the classic, you see on the top, this is CLB or classic load balancer. I see Saurabh. If I refresh it, I see Ashfaq. If I refresh it, I see Saurabh. If I refresh it, I see Ashfaq. It means load balancer is sending it to instance 1, then 2, then 1, then 2. Okay, so that was what we actually wanted to say also. Have a look over here. It says Saurabh, Ashfaq, Saurabh, Ashfaq. It means classic load balancer is indeed working the way we wanted it to work. Now, if this is understood, let's go to the next load balancer, which is my application load balancer. Now, sometimes actually error might happen. Just press the Control R button on your Windows or Command R button on your MacBooks. Okay, and it should take you. Now, same story here. I will name it as ALB, which is working inside this one. It's working inside 1A and 1B. Next, add the security group if you want here. So I had already created one, so I am using that. If you want to create new one, you can do that. So let me create only anyhow ALB hyphen port 80 and ALB hyphen port 80 created on this, and that's working on port number 80 HTTP. Next, you can go and add. Now, inside a classic load balancer, you actually go and add the instances to the load balancer straight away. Here, you don't do that. Rather, you add something known as a target group, and you add the instances to the target group. Okay, so I'm naming it as target group hyphen application load balancer here. And in the next step, I will go and add the targets here and add to register. Then review and create. And finally, if everything is done, my application load balancer should be up and running. Now, needless to say, it won't respond back straight away because it has to pass the basic health check first. So meanwhile, while it goes from provisioning state to active state and it actually starts working the way it has to, let's go and create the next one, something known as network load balancer. Okay. In the meantime, if you go to CLB, earlier you saw 0 of 2 instances in service. Now it says 2 of 2 instances in service, and the instances also will be in service and in service over here. Okay, 1A, 1B. Same thing should happen with ALB very shortly. Right now it is provisioning though. So let's go to the last one, which is network load balancer, used when you have to work on millions of requests per second. Very fast load balancer. So click on create over here. Let's call it as NLB hyphen, NLB is fine actually, TCP, and I want you to work on 1A and 1B. Why 1A and 1B? Because my instances are also on 1A and 1B. Okay, so next routing here, you will go and create a new target group. Let's call it as T target group hyphen network load balancer. And then again, the same old story, go add it, review, create, and my network load balancer will be created. Now this again will take some time and it will add the machines and it will be active. But if you see, my active or application load balancer is still up Okay, it's up. Let's go and work on that. Copy it here and this, and it will actually start pointing it to either Saurabh or Ashfaq. See, Ashfaq, Saurabh, Ashfaq, Saurabh. This is my application load balancer. Okay, so application load balancer, classic load balancer, network load balancer. My load balancers are actually created. The type is also telling you this one is application, this one is classic, this one is network. This again will take some time in provisioning. While it is doing that, let's go to a few other things, something known as a reserved instance inside AWS. Now, you see, your AWS instances are pretty expensive to run. If you remember your DynamoDB, there we had, okay, in fact, let's go to DynamoDB and see for ourselves. If you remember, we had talked about the capacity inside DynamoDB. You can go and pay AWS for whatever usage you are doing for the reads and the writes on the table. Alternatively, you could have gone and bought something known as a reserved capacity. And you understand you will save a lot, approximately 80 to 90% if you go for the reserved capacity. So same concept here also. You can go and buy a reserved instance. If you go and buy it, let's say I'm buying it for 1 year, I will be paying everything upfront. I have to go for, let's say, a R5A large instance, which is of Unix, which is default, and I don't want to change it. There are two options, standard or convertible. Standard means I will for the next 1 year remain on R5A large. Convertible means I can go and change it. Let's say R5A large to R5A X large. In that case, you only have to pay the difference between the instances. So let's say I'm going for a standard and I click on search. I just have to pay $366, and that's pretty much it. Nothing else I have to pay AWS. Now, the same thing if you had gone elsewise. So let's go back to our AWS calculator and have a look at how much can I actually save. So the instance that I'll be referring to will be R5A large. Okay, so let it open up. Here, create estimate. Let's go for EC2. And I'll change my region to AWS in Mumbai. So goes here. And we had gone for R5A large, right? Okay, here. And let's go for R5A dot large, 2 CPU, 16 GB RAM. If I was going like this, I will have to pay $55 a month, basically $56. 55 multiplied by 12 is $660. 660. If you go and buy it up front, you have to pay only 366, almost half basically. So you understand that if in case you have to go and buy the cheaper instances, you can go for this one. Want to save even more, go for 3-year plan. Here you only have to pay $700. In this case, you have to pay 55 into 12 into 3, which will be 660 into 3, which is $1980 or $2,000 for 3 years. Here you only have to pay $700. Do the mathematics yourself. You only are paying $700 in place of $2,000. So this is something known as a reserved instance, wherein you have to pay a lot less if you have to go and buy the instance for duration of 1 year or 3 years. While it is happening, let's go back to our load balancer. And if you remember, my network load balancer was not working some time back. If I go and do this now, I will actually see it pointing to any of the instances, which can be either Saurabh or it can be Ashfaq. Okay, so my network load balancer also works, classic also works, and application also works. So these are the 3 types of the load balancers. Now, while we are over here, let's go to the auto scaling also. Now, auto scaling simply means, assume this, I have my, let's say I have a big sale coming up. So I know that many people will go and log into my instance or to my server at that time. The load on my server will certainly increase. In this case, I want to add more instances automatically. But how will that happen? How will the instance be added automatically? Now, there are two options for it. First option is I can have my instance T3A small. I can change it to T3A medium, T3A large, T3A X large. One option. This is known as vertical scaling. My single instance is automatically scaling up. Alternatively, instead of having one instance, I can have multiple instances. Instead of having one instance, I can have 10 instances. This thing is known as horizontal scaling. Now, advantage of horizontal scaling is you will never have downtime. Vertically scaling, one instance is only there. No, T3A large, T3A X large. If that instance goes down, your entire server goes down. Whereas with horizontal scaling, at least one instance is always running. Okay, so I generally, or rather we actually prefer horizontal scaling. But if you need horizontal scaling, you should also have what to scale, what machine to scale. If you need a machine to scale, you need the backup of the machine. The backup of the machine is known as AMI or image over here. But how do you create an image? For that, simply select your instance, click on actions, click on image, and click on create image and name it. So let's call it as web server, and description, let's say web server on or bracket Apache, and just click on create image. If you do this, your AMI will be created, which will show up over here inside your AMIs. Okay, and this AMI can be used to go and create multiple instances in parallel. Okay, so that's your AMI over here. Let me name it as, let's say, web server -Apache. Okay, while this AMI is being created, let's go and talk about the other things over here. Instances, we understand, we can go and create any instances. The instance types, we understand. Basically, what are the types of instances? T2, T3, T4, T3A, M5A, M5AD, M5AN, and so on. These are the instance type. Then you have something known as a savings plan. Saving plan basically mean you can go and commit to AWS that you will be paying this much price for each hour. Once you do the commitment to AWS, AWS will charge you way less for those instances. This thing, you have actually seen something like this inside your reserved instances, actually, if you go and buy the reserved instances over here. Okay, though still, if you want to go and do that, you can click on savings plan and you can say that I need it for 1 year, and each hour I will commit to pay $1 and I will pay everything all upfront, which means AWS will tell you that for each year you have to pay $1,760. If you can pay this much, you click on add to cart, the next instances which you work on will be charged pretty less. That is something known as a savings plan. Now, a dedicated host, on the other hand, is when you go and buy the whole big server yourself. In this case, you have whatever families you have seen. So let's say I want a C5. In this case, C5 inside 1A. So in this case, if in case you go and buy a dedicated host, this complete server is given to you for your use only. And you can launch as many instances as you want over here. Now, this thing advantage is that you own this server actually. No one else can create anything inside this. And needless to say, you don't have any T type of an instance over here. So if you see only this one, you don't have any other A, T4, T2, or any other instance over here, because those are the burstable instances. Okay, so going back, if I have my AMI over here, my AMI is still pending, fair enough. In the meantime, let's go to spot request. Now, a spot request is a request. So let's say AWS has 100 servers which are inside Mumbai at the moment. Out of that, 80 servers are being used and 20 servers are not being used. In this case, for those 20 servers which are not being used, AWS will charge you very less. These instances or these unused instances are known as a spot instance. Advantage of a spot instance is it is very low, or it is at a very low price for you to use. Disadvantage is AWS can take it back at any point of time. The reason for that is initially AWS said that 20 instances are not being used, so I will give these instances to you at a very cheap price. But what if someone else goes and buys either a reserved instance or a normal on-demand instance? This instance that you use, you create from here, is actually known as an on-demand instance, because you can go create and or terminate it at any point of time. This is known as an on-demand instance. So going back, if in case someone goes and buys the instances and AWS doesn't have any instance with itself, it can go and take your instance away. In this case, your spot request is actually deleted. But the advantage is that you can have instances at a very cheap price also. So how to do that? Just click on request a spot instance over here and tell what type of instance you need. Now, obviously, you will need a AMI in this case. If you have your AMI, which is created like what we were doing earlier over here, if the AMI has been created successfully, it will actually go and show up over there. Okay, I believe it is still in pending state as of now. Let's have a look. Okay, it's available, fair enough. Then let's go back to our spot request here. This part here, and if I click on request a spot instance, and now in this case, if I go and take any of the AMIs which are available, it can also have my AMIs, by the way. Okay, so whatever AMIs you want, you can go and take that AMI. If you have your own AMI, you can choose that. Like I had my AMI, I can choose that. If you want a specific, like let's say Ubuntu 16 or Ubuntu 20, you can go for that also. And next, you tell that you need it inside what VPC, what availability zone, what key pair, how many instances will you actually need. And AWS is saying that, okay, these are the instances which are available for you to use. The advantage of this is that you are saving a lot of money. How much? 86%, 68%, 69%, 45%, and 73%. So basically, AWS will go and create the instances for you automatically, and you can do whatever job you want to do inside that spot request. So this is what is meant by a spot request. Now, finally, let's go to our auto scaling. Auto scaling simply means that if in case the load on my servers are more, I can automatically add or remove the instances from my spot request. For that, you should know two things. First is what to auto scale, and second is when to auto scale. What to auto scale means what instance to auto scale, what is the AMI that has to be used, and so on. For that, you can click on your launch configuration over here. You can click on, okay, just have a look at the header itself. That will tell you LC, launch configuration. Okay, so click on create launch configuration, give it a name. So I am saying it as LC-1, and then I can choose whatever AMI I need. I already have my AMI, right? My server AMI. So let's take that web server here, and whatever instance type I need. So I'm saying that I'll go for T38 dot, and let's say micro instance here. Okay, then if you want, by the way, you could have also gone for the spot request, what we have talked about some time back. And then if you want to go for monitoring, if you want the EBS optimized instance, you need what type of volume. If you have a security group, the same thing that we did inside our EC2 servers actually. If you want, you can go for a key pair. If you don't want, you can choose without a key pair. That is also fine. And click on create. So in this case, just go and give what all IPs are allowed anywhere, let's say, and create launch configuration.
And if you go and create a launch configuration, what to auto scale is already decided. Next step is to decide when to auto scale. You say that I have 10 servers, increase it to 12 or 13 or 20 or bring it down to 2. On what basis do you want to do that? Same thing inside DynamoDB was known as my read and write capacity. Same thing inside EC2 is known as auto scaling groups. How to do that? In that case, just click on auto scaling group, click on create auto scaling group, name it something. Let's call it as ASG-1, and it will use my configuration, which I have already created here. Then it will go inside my VPC, inside 1A and 1B. Next, if you have a load balancer, it will actually show up over here. You see, your load balancers are already available. If you have a classic load balancer, it is already showing because I already have a load balancer. If you want, you can add it to any one of them. Okay, associated. So this is not because these are not available. These two are available. In this case, my machine will automatically be added to my application load balancer, and it will be added on what? So just like your DynamoDB, where you had your minimum, maximum, and how much are you using. So I say that, see, I think I should be needing 2 instances always. If in case I don't need anything, bring it down to 1, at max go up to 4 instances. The same thing that you had done inside your DynamoDB. So I think I should be requiring 2 instances. If no load is there, bring it down to 1. If too much load is there, bring it up to 4. But on what condition? That condition comes up over here inside your scaling policy. Please remember, there are only 4 conditions here. CPU utilization, network in, network out, and how many requests your load balancer is getting. In this case, you will say, I believe whenever my CPU utilization goes above 80%, you should go and do that. And if you want, you can also add the notifications basically. So in this case, the notifications will automatically be added in case a machine is being added or removed from the load balancer. And if you click on next and finally click on create auto scaling group, this auto scaling group will be created. And if in case my CPU utilization goes above 80%, my instances will be added to my load balancer automatically. How many instances? At max 4, minimum 1. Now, if everything is good, based on the conditions, you will see your instances will automatically start to show up inside your instance tab over here. This, by the way, remember, is your on-demand instance. To bring the bill down, you can either go for a spot or a reserved instance. Going back to my instances, you see automatically the instances are added over here, this one and this one. And by the way, if you go to your load balancers, because we had talked about the application load balancers over here, this one, and if I go to this particular target group, you will see the instances are automatically being added to my load balancer. So this is how your load balancers, auto scaling, EC2, spot request and all are being added one after the other. So have a look over here. You see all the 4 instances are coming up. Now this instance and this instance is going into unhealthy because it is still actually doing the provisioning. Okay, alternatively, you might want to go to your instances and have a look at the security group to see if this security group is actually allowing port number 80 or not. Okay, if it is not allowing, obviously it won't work, no? Which I want to believe is not happening, yes. So edit inbound rules and add rule, and you can go and make it 80. And let's say it from anywhere. So in ideal cases, you will select that specific security group only, which should allow. So if you go back to your load balancers now and go to your target group, eventually you will see that all the 4 instances are actually added to your load balancer. Okay, in some time, this will also become healthy over here. Okay, that depends on your health check. If you want to go and change it, you can do that. Healthy threshold also, let's make it 2 over here, and let's make it as 10 maybe. Save. So in some time, you should see that your instances, these 2 instances are also healthy. Okay, and this is how your auto scaling
actually works inside AWS. So we do understand what the instances are, we do understand what the AMIs are, we do understand how the storage is kept inside EBS, we understand about the security groups, we understand about the load balancers, and we understand about the auto scaling. So this in short is how your AWS EC2 concept works. Go back over here and see all the 4 instances are healthy, which means that if in case the load is more, it will go up to 6. If it is less, it goes down to 4, because based on the settings that we have done, because 2 instances were already added. Now, if in case you have to remove it, you might want to go delete your first auto scaling group. So let's delete that here. Because if you don't delete it, remember that AWS will continuously keep on adding the instances. Okay, so on production, actually don't go and delete it because we are doing it as of now. We'll just go and delete this. We'll go and delete our launch configuration also. Pretty straightforward. Okay, this here, actions, delete, deleted. Then let's go to our load balancers and delete all the load balancers also. Again, this in production you won't be doing. Actions, delete, done. If this is done, let's go to instances and instances over here. And because your auto scaling group is being deleted, so your instances also will anyhow be deleted in some time. Let's go and terminate these instances also. Okay, so this basically is, and by the way, there is one new thing, something known as a EC2 Global View, pretty new, actually launched less than 30 days back. The concept here is that it tells you across all the regions what all instances are working, how many security groups are there, how many VPCs are there, how many volumes are there, and so on. So provided you have the policy which actually allows you the global view, straight away looking over here itself, you can understand how many instances are actually working and how many instances are there. So if you see, just for looking at this, I can understand for some strange reason, I have one instance which is in Northeast South in Korea, basically. Okay. So I never knew I have created an instance over there, but good actually, because looking at this itself, I understand that I do have an instance in Seoul. Okay. Click over there and it is telling you that you have an instance over there. Click over there and it will take you to that region. And if you want, if you are not using it, basically, you can go and terminate it. Like in my case, I'll do. It's a pretty good thing because straight away looking at a global view itself, it will tell you if at all instance is working or it's running, and if in case you need it or not. Not the organization level, because you work on specific regions only. So this thing will actually come in handy over there. Okay, so basically this is how you work with EC2.